Okay, so the purpose of this little video, just to explain why we use one graph versus the next. Ordinarily we do a little of this in class, but just brainstorming. Suppose you had some, I don't know, some vehicles. Yeah, you run a little car lot. Yeah, sure. And you sell some Chevys and some Toyotas and some Jeeps and some Fords and Nissan. I don't really care. Whatever. And so you've kept track. And so for this month, you've kept track, and it looks like this. And it looks like you've got, you sold 50 of these, and 30 of those, and 10 of these, and 60 of those, and 10 of these. And you'd like to make a chart. Well, we would best accurately describe what you want to do. So the question might be, what do you want to say by that? If you're presenting this and you want to talk about what percent of the total is Chevy, it's 80, 90, 150, 160. So it's 50 out of 160, which is just for fun. Well, yeah, it does, 516, so 31%. So about 31% of this circle would be filled in, Chevy. And you're like, oh, so at a quick glance, and of course the computer's going to do all this work for us. I'm just showing you where it's coming from. Just a little bit more forward. Now notice that should be a little over 50% total, right? So I'm going to go a little bigger here, a little bit bigger here. So there you go. And then, 10 out of 160 would be about 6% Jeep. And about same size Nissan, of course. Yeah, let's just make this a little bigger. There's my Jeeps. Here's my Nissans, let's say, and then what's left over should be Toyota, and of course this isn't to scale. But the idea that when we do a pie chart is always about percentages. It's always about percentages. What percent of my sales were Toyota? What percent were Chevys? What percent were whatever? Because in this case, I actually care about percentages, not totals. For instance, coming to budgets. You want to talk about your budget. What percent of my money am I spending on clothes? Listen, I don't care how much money you make. If you spend like 40% of your money on clothes, you have a problem. You should fix that, okay? I don't care whether that's 40% out of $10,000. That's a lot of money. I don't care if that's 40% of $1 million. That's a lot of money. That's a lot, okay? I don't care about the number. I care about what percent is it of the total. And so percentages. Every time you want to talk about a percentage or you want to show that, hey, most of our stuff is here, most of our stuff, we have very little here, percentage-wise, that's what you're talking about. You want a pie chart, okay? Now, the same data, of course, could be shown in what is referred to as a bar chart, of course. And I'll go in this order for a reason right now. And those are all exactly the same width of bar, in case you're wondering. And the idea here is, of course, just showing total raw numbers. Okay, this has two names. Of course, you can look at it as a column chart. That's the general terminology for it. It's a column chart. If you put the same thing coming in from the side, technically this is called a bar chart when it comes out from the side. Okay, a column chart is the vertical ones. Okay, I don't really care what you call them in terms of, I won't mark you down. If you're right to call that a bar chart, I won't mark you down. Now, which one comes first? Should it be Chevy because that was what was listed first? Should it be Chevy because it's the alphabetical order? The right answer is it doesn't really make any difference. However, from years ago, the convention has been you put the tallest bar first when the data down here is what we refer to as categorical data. It's categorical data. You're a Chevy or you're a Ford. You fall into a category. If you have categorical data, traditionally we put the tallest bar first. We go from tallest bar to shortest bar. And when we do that, we refer to this as a Pareto chart. Again, a Pareto chart is just a specific case of the column chart where you go from tallest bar to shortest bar. No one's going to mark you down. That's just typically how it's done. Now, I usually make a big deal about this in class. Always include a title. Okay, always, always, always include a title on every graph you make. Make sure it is specific, not just eye color, not brand of car. This is the cars sold at Jay's used car lot in December of 2013 or whatever it is. Okay, be specific. Okay, also make sure you include percentages on the pie charts whenever you use them. Okay, and in the video I explain how to do that. Always use percentages. Don't use the raw numbers because that confuses people. Okay, now it's quite possible at times we have data that looks like this: male, female, great, whatever, and then oh, I don't know. Carb? No, not cars. It's boring. Yeah. Mustard, relish, ketchup, and of course sauerkraut. So little topics of what kind of things they prefer on their dogs or whatever. So, you know, it might be something like this: 30 and 20, and then like 10 and 40, and then 10 and 10, and then 70 and 60 or whatever. I don't know. Then what you could do, because we have both a row and a column label, is you can do what's called a side-by-side column graph or column chart. And so what I can do then is have ketchup, and then of course I'd have male and female, and then I could have 30 and 20. Then I could have, oh, I'm sorry, that was mustard, sorry. Mustard. And then relish, male, female, and break that out by like that. And then ketchup. And then sauerkraut. Nice. Okay, and that'd be a side-by-side bar chart. Now, Excel does those for you. If your data is like this, that is, you have it broken out like this, and I give examples of that in the video, it will make them this way. You can automatically have Excel flip them around, and you can do the male and the female, and you get all the male condiments side by side. And then, of course, it would be mustard, relish, ketchup, sauerkraut, mustard, relish, ketchup, sauerkraut for the women. Or whatever, okay? But side-by-side bar chart, we want to keep track. Maybe you want to see how the freshmen, sophomores, juniors, seniors doing in the different math classes. I don't know. And that's a pretty good way to do it. Okay. Another one that we'll see is the idea of what's called a stacked bar chart. And for this one, I'm going to go ahead and use the computer. I'm going to copy this data into my Excel. So just allow me to demonstrate this. So the way this will get typed in is you go mustard, relish, ketchup, SK, male, female, okay, so there's my data. Let me make it bigger so you can see it better-ish. Okay. Again, once the data is in here, now you'll be using, for the graphing assignment, you'll be using pivot tables to crunch this data. But for this case here, I'm just going to go insert. I'm going to go to, I can do it two ways. I can either do it here in recommended graphs, or I can do it in this. Click on this guy here. Boom, there it comes. Comes up with a side-by-side bar chart. Again, don't forget to edit your title. And here's how we did it the first time. You're like, I don't really like it that way, Jay. So if you come up here and click on that, you can switch the rows and columns around. And there you have it. Okay. So whatever makes you happier there, that's how you do it side by side. Now, let's say I don't want a side by side. Let's say instead I want to do it a little differently. So watch carefully. Another one you can do is what's referred to as a stacked bar chart, which is this guy right here. So a stacked bar chart just says this. For mustard, I have this situation going on. There were 50 people that like mustard. What you can see is most of them are male that like mustard. And then most of the ketchup, or most of the relish people are clearly females. What this looks like, it looks like not a pie chart, more of a brownie chart, if you will. You see that? So this is you can see the percentage. Like 60% of the mustard people are women, if you will, and maybe a fifth of the relish people are female or male, and so forth. And you can see those. And so this is what's referred to again as a stacked bar chart. Okay? So pretty good stuff there. Again, gives me, it's kind of like making pie charts, multiple pie charts all at the same time, which simplifies the guy's life a little bit. I can kill two birds in one shotgun shell, as it were. Okay? Now, those are all fine graphs, and you've seen most of those in the past. I'm sure you've seen them around. The question maybe is, why did they use that one versus this one? That's kind of the point, again, of today's lesson. And then also you will see things like people's ages. Okay, which is obviously numeric data, which that's the first time we've done numeric data. Everything else has been categorical data for Chevy, Dodge, red, blue, yellow, freshman, sophomore, junior, whatever. They're categories. You fit into a category. Okay, but in the case of ages, if you have people that are lined up, they're anywhere from, like, I don't know, let's say the youngest person was 18. Like, I need to put all these people in groups. So I can have the teenagers, the teens, the 20s, the 30s, the 40s, the 50s. And the idea there being is you'd break them up into natural things. There's 2 in this column, 1, 2, 3, 4 in this column. 30s, 1, 2, 3, 3 in this column. 40s, 1, 2, 3. And 1, 2, 3 for the 50s. And the idea would be that, okay, your teens go from, well, let's just say they go from 10 to 19, if you will, right? So from 10 to 19, you're a teen, right? There are 2 people in this group. And now at 20, which starts, in essence, if you're older than 19, you fall in the next category. Well, it's twice as big then. So from 20, where that bar starts, to 29, you see, and that's how you do it. Now, 2 things come to mind. There needs to be a cutoff in between here. So back in the old days, we made a big deal about this. We talk about, okay, now we're going to have the class boundaries. We might go from 10 to 19. But in reality, if you're from 9.5 years old to 19.5 years old, maybe we would call that's 10 wide, we'd call it the teen years. And if you're bigger than 19.5, from 19.5 to 29.5, you'd fall in the 20 category. Okay, and that was the idea that when somebody, once they're past about 6 years old, you quit counting halves. So if you're 19.5, you ain't really 19.5, we'll round you up to 20. My wife started calling me 50 years old when I turned 40. So when it hit 50 this year, it didn't hurt as bad, which was weird. But anyways, so that's the idea. And this is what's referred to as a histogram. In reality, what it is, it's just a grouped, it's grouped data. And that's all you're doing. You're grouping the data, and then you're graphing what we refer to as the frequencies. There's 2 in this category. There's 4 in this category. There's 3 in this category, and so on. It is imperative that there be no distance between these guys. Watch the video. I show you how to get rid of that distance. If I left a distance between the 10 and the 19-year-olds that was about that wide, one would think that, hey, this is 10 and 19. This is 20 and 29. This looks like there's something missing here. So it's imperative we slam these bars together when we do a histogram. And again, with the exception of Google Sheets, Google Sheets can't do it, but the Excel can do it. Make sure you slam those together. And again, you'll pick that up from watching the video. Just one more graph. I just about forgot about him. And that is the time series graph. So you'll get data that looks like this, time, and it'll be something like population. So it could be like the year 2000, 2001, 2002, 2003, and so forth. You could count by tens. You could count by whatever you like. I don't know. Make any difference to me. Count by minutes if you like. So if one were to do this, if this was 2000 right here, we go up here to 100. And 01 puts us at 120, let's just say. So boom, boom, we're going to draw a line. At 2002, we're at 160. So boom, we draw another line. 2003, we dropped off to 140 or so. So we draw another line. 2004, we just barely tick up to 150. In 2006, there's 5 rather, we're at 170. 2006, 180, and then 2007, 195. And so it's a pretty straightforward little graph, easy to do. What you can do in Excel makes it, of course, everything. Excel makes everything better, friends. So if one were to do this, one would simply type in the dates, and what you can do is actually this cute little trick. The computer knows what you're doing when you tell it this. It needs 3 numbers. Highlight all 3 of them. And then click on a corner of them and drag them down. And that's 2000. Oh, I only wanted 7, didn't I? So let's get rid of those. Cool. And then just make it bigger. So they got 100, 120, 160. Shoot. What happened? Darn it. 160. Open. What happened to my thing? Okay. 140, 150, 170, 180, 195. Highlight them. This is important. A lot of people will screw this up. You think I want a line chart. You do not want an XY line. You want a scatter plot, but you want a connected scatter plot. And that right there is a time series graph. What are we looking for? I am looking for what is the trend over time. Yeah, it dipped down in 03, but overall we've been steadily increasing for the most part. Okay, that's what a time series is about. We use that a ton for modeling. In fact, if you've been paying any attention at all, the virus, quote unquote, talking about models, the idea is you're trying to predict what the model is going to look like, looking at trends and data. I would argue that their model has been pretty shabby, and this is obviously just a one variable, but what you do is you'd be tracking it over time. Yeah, their model has other things in it in terms of predictor variables. This is simply graphing over time. What does the thing happen to be doing? And at some point, in the virus deal, it's going to crest and then it's going to come back down the other side. Okay. And so that's the game. Those are the graphs that I want you to feel comfortable with, and I hope that helps explain kind of why we use them. Bear in mind the whole point of a graph is to make things easier to read. So if the graph is confusing you, you've done it wrong. The whole point is to make my life and the people who are watching my presentation understand what I'm trying to convey faster and easier, not harder and more convolutedly. Okay.